nice to see you again today. I guess I can't really see you, can I? At any rate, we are going to be working on the chain rule today. And the chain rule, is just one of those derivative rules. We got the power rule, the product rule, quotient rule, the constant multiple rule. Lots of rules in this class. Uh, the most important rule, though, here is the chain rule because it kind of encompasses the rest of the rules all at the same time. So let's look at the reason why we need the chain rule. Let's take, for instance, the derivative. Let's take the function f of x equals 2x plus 3 to the third power. Now our intuition tells us we should simply do a power rule 3 times 2x plus 3 squared. Alright, but is that correct? Well, let's see. 2x plus 3 cubed. 2x plus 3 cubed is really, let's see, let's multiply this all out. That's 4x squared plus 12x plus 9. That's 2x plus 3 squared, so I need another 2x plus 3 here. That gives me 8x cubed. I got a 24x squared. I got an 18x. Now distribute the 3. I got a 12x squared, a 36x, and a 27. Well, that's 8x cubed. There's 36 total x squareds. There's 54 total x's, and a 27. So that's my function. So my derivative, then, it stands to reason. This is normal derivative stuff here. It's 24x squared plus 72x plus 54. That's my actual derivative. That was a heck of a process. So let's see if our little shortcut method up here worked. Is that equal to 3 times 2x plus 3 squared? Well, that's 3 times 4x squared plus 6 plus 12x plus 9. And I think we're going to quickly see that that is not true. 12x squared plus 36x plus 27. Well, you may be looking at this close and saying, wow, we're pretty close. So I just need to do my power rule and then double it because this is exactly half of that. Unfortunately, that is not always the case. In this particular case, it is, and I'll show you why. So let's go down here and let's look at that exact same function again. F of x, we said, was 2x plus 3 to the third power. Well, if you think back to your pre-calc courses and your Algebra 2 courses, you talked about something called the composition of functions. So I'm going to ask you, what two functions make up f of x? In other words, if I ask you to come up with an h of x and a k of x, and I want you to rewrite this as the composition of those two. How can we do that? Well, the inner function is 2x plus 3, so that's got to be my k of x. And my outer function is a cubic. So if you think about this, if I compose these two, put 2x plus 3 inside of h of x, I get 2x plus 3 cubed. So I've written it as a composition of functions where I have an inner function and an outer function. Okay, so we have identified this as a composition, which tells us there is a need to do the chain rule. So in order to actually take the derivative of a composition of two functions, or 3 or 4 or 5, you have to follow the method which is called the derivative of the outside times the derivative of the inside. So simply stated, in this particular case, we are going to take 2x plus 3 cubed and apply the power rule for the outer function first. The derivative of the outer is 3 times 2x plus 3 squared. I applied power rule to x cubed, 3x squared. But remember, 2x plus 3 is composed inside of there, so it's 3 instead of x, it's 2x plus 3 squared. And then I now need to take the derivative of my inner function. Well, my inner function is 2x plus 3, so its derivative is times 2. And that, hopefully you notice, is or was the difference that we had up here and we took our derivative. This was exactly half of what the actual derivative was supposed to be. So if I throw this times 2 in there, I can then confirm that these two are equal. So this times 2 is what I was missing because I never took the derivative of my inner function. That is the chain rule in a nutshell. Let's take some examples. Let's look at, for instance, f of x equals the cubed root of x cubed minus 5 squared. Well, that appears to be a lot of different functions, but we're pretty smart. We can rewrite that. We know cubed roots are the same as 1/3 powers, so I can write this as a 2/3 combining it with this 2. And now it looks a little bit more manageable. So power rule says 2/3 x cubed minus 5 to the negative 1/3, right? Subtract 1, and then don't forget the chain rule says 3x squared. So when we simplify this, we'll get 2 times 3x squared, or 6x squared, all over 3, right? This is part of our denominator, and this is a cubed root of x cubed minus 5. So there is our final derivative. Actually, this would be our final derivative. The 3's would cancel out here. All right, boom, boom. See you later. We end up with 2x squared over the cubed root of x cubed minus 5. And that would be f prime of x. So here's an interesting question for you. Let's look at a problem. We've had problems like this already. Oddly enough, you're probably wondering why they worked. We had problems before where, let's say, we're given g of x, and g of x is x minus 5 squared. Well, we were simply able to do the power rule on that and get 2 times x minus 5 to the first. But you actually did the chain rule without knowing it because the derivative of the inside is simply 1. So it is useful to understand why the chain rule is needed, why that times 2, or in this case that times 3x makes a difference, 3x squared here. You need to know the derivative of your inner function ahead of time. If that derivative is 1, it's not really a chain rule problem, but yet it is. Okay, so do look into that. If the inner function is a little more complicated than a linear, then you're going to have something a little more difficult to work with, and specifically linear with a slope of 1. Because remember, derivative is slope, and if the slope is 1, you're not really affecting anything at all. Let's look at one final example here. We'll call it h of x, and h of x will be negative 7 divided by 3x minus 7 quantity squared. We know from doing the power rule that we should probably rewrite this guy. Although we do know the quotient rule right now, it's still going to be a little bit easier, in my opinion, to rewrite this as a product slash power rule by negating our exponent. So my derivative will then be, the power rule says, multiplied down, so I get 14 times 3x minus 7 to the negative 3. Remember, we're subtracting 1. And then don't forget, derivative of the inside says times 3. So I end up with 42, 3 times 14, over 3x minus 7 to the 3rd power. And that is what we have for the chain rule today. It was very nice of you to listen. Thanks.